Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all. Today's presentation on vector integration, in particular the line integral, part 1. An overview of today's presentation is, first I would like to introduce the vector integration, then some definitions, closed and smooth curves, circulation, and what is the line integral, then conservative force field, work done, and problems on line integral. Now, vector integration. Simply, if a vector f bar is given in component form, that means f1 I bar plus f2 j bar plus f3 k bar. Here, f1, f2, f3 are called components of the vector. If a vector is given in component form, evaluation of integral of this vector f bar is simply to evaluate the integral of its corresponding components. That is, for example, if f bar is a given vector, then integral from a to b f bar of t dt is I bar into, let us integrate the first component with respect to t, then plus j bar into integrate the second component and k bar into integrate the third component. So, simply this is the evaluation of integral of a vector. Now, coming to a line integral. A line integral is the generalization of concept of definite integral, integral a to b f of x dx. So, the generalization of concept of definite integral is the line integral. Similarly, we can define the surface and volume integrals also. The surface integral is the generalization of concept of double integral. So, here double integral f of xy dx dy. Here there are two integrations. So, one is with respect to x and the other is with respect to y. So, we integrate the function first with respect to y and then with respect to x, or first with respect to x then with respect to y. So, this is same as double integral f of xy dy dx also. Both gives the same answer. And coming to volume integral. Volume integral is the generalization of the concept of triple integral. Simply evaluate the given vector function with respect to three variables x, y, z. So, triple integral of f of x, y, z dx, dy, dz. Here we need to integrate the function with respect to z, then y, then x, or else we can change the order also. First we can integrate with respect to x, then y, then z, etc. Now, a closed curve. For example, if there is a curve with the initial and terminal points capital A and capital B. So, here A is the initial point and B is the terminal point. Now, if these initial and terminal points coincide, that means, for example, here the point A. Now, let us consider the terminal point B at the same point A. That means here A and B are coincide. A and B coincide. Therefore, this curve is called a closed curve. The best example is a circle or a triangle, which is a closed curve, or a square, rectangle, and so on. These are closed curves. Now, smooth curve. A curve r bar equal to f bar of t is said to be smooth curve if this function f bar is continuously differentiable. That means all the successive derivatives must exist. Then the curve is said to be a smooth curve. And line integral. Let us consider a smooth curve r bar, that is equal to f bar of t. And along the curve C, joining the points A and B. For example, this is the curve C and from A to B. So, in this direction. Then, and also let capital F bar of R is a vector point function. Then the line integral is denoted by integral A to B f bar dot dr bar. So, here we need to calculate first f bar dot dr bar. F bar is the given vector, and what is dr bar? We know that r bar is the position vector given by xi bar plus yj bar plus zk bar. And what is dr bar? Simply differentiate it. dxi bar plus dyj bar plus dzk bar. Now find the dot product between the given vector and this dr bar. Then integrate between the limits. And here the main point is the line integral means we evaluate the integral of the given this f bar or dr bar once only. So single integration. That means the result of this f bar or dr bar must be in the form of a single variable. For example, if we have x square y and we are integrating with respect to x, how we can integrate this y? This is not multiple integral, this is single integral. So in that case, we transform y also into x. So y should be transformed into x. For example, if we are integrating with respect to y, then transform x to y. Our ultimate aim is to write this function in the form of a single variable. Then only this integral is possible. Sometimes we transform both x and y in terms of another variable like t or theta. Write x in terms of t, y in terms of t, and find the limits of t and integrate. So like that we evaluate the line integral. And simply any integral which is to be evaluated along any curve is called line integral. If we are evaluating the integral along a curve, then it is said to be a line integral. That means along each line. Next, circulation. For example, if v bar represents the velocity of a fluid particle and c is the closed curve, then the integral v bar or dr bar is called the circulation of v bar. So we denote the circulation using this line integral with a closed curve here. So this indicates the c is a closed curve and v bar or dr bar is the circulation of v bar. For example, if v bar dot dr bar, the line integral of v bar dot dr bar is 0, then the field v bar is called conservative. That is, no work is done and energy is conserved. So if the line integral is 0 and v bar represents the velocity of a fluid particle, then no work is done and the energy is conserved. And the next concept is work done by a force. For example, a particle is moving from a point A to another point B. How this particle moves? For example, we are applying some force F or F bar on that particle. So by applying this force, the particle is moving from A to B and hence some work has been done. So that work done, W, is calculated using the line integral. Simply, if F bar is the force vector acting on a particle moving from A to B, then the work done W is given by the line integral A to B F bar dot dr bar. So if this F bar is the force vector, then the line integral is called the work done. If F bar is conservative, then F bar can be expressed as F bar equal to del phi, where this phi is called the scalar potential. So in this case, since F bar is del phi, curl F bar will be 0 bar. So a conservative force field is also irrotational. Now let us solve one problem on line integral. So here the question is, find the work done by the force vector F bar in moving a particle from 0, 0, 0 to 1, 1, 1 along the curve C, x equal to t, y equal to t square and z equal to t cube. So here the vector F bar is given and the points are given 0, 0, 0 to 1, 1, 1 and the curve C also given. And we know that what is the work done? How can we find the work done by a force vector? W is line integral F bar dot dr bar. And that F bar is given. F bar is 3x square minus 6yz I bar plus 2y plus 3xz j bar plus 1 minus 4xy z square k bar. And what is r bar? xi bar plus yj bar plus zk bar. To find the work done, first we need to find this f bar or dr bar. So, dr bar is dxi bar plus dyj bar plus dzk bar. And therefore, to find the work done, we need to calculate f bar dot dr bar first. So, therefore, f bar dot dr bar, the dot product between two vectors, which results as a scalar. Since I dot a is 1, j dot j is 1, k dot k is 1. And here, f bar dot dr bar means the sum of the products of corresponding components. So, 3x square minus 6yz dx plus 2y plus 3xz j bar, 2y plus 3xz dy plus 1 minus 4xyz square dz. So, we need to integrate this f bar or dr bar, but here we are finding or evaluating the line integral, that means single integral, but here we have x, y, z, dx, dy, dz. So, three variables are there. How can we integrate with respect to one variable? For that, we use the given curve C. And what is given? Given C is x equal to t, y equal to t square and z equal to t cube. So, that means we can transform these three variables x, y, z into t. If we transform x to t, we need to transform dx also. So, let us differentiate. Dx is dt, dy is the derivative of t square 2t dt and dz is 3t square dt. Therefore, f bar dot dr bar is given by, once again go back to the previous slide, 3x square minus 6yz, 3x square minus 6yz. So, since x is t, y is t square and z is t cube, let us substitute all the values here into dx. What is dx? dt. This is the first term plus second term 2y plus 3xz, 2y plus 3x into z, dy is 2t dt plus the last one 1 minus 4xyz square, 4xyz square, dz is 3t square dt. Now, we can observe that this f bar or dr bar is completely in terms of a single variable, that is t. So, here 3t square minus 6t power 5, we can take this dt common plus next term 2t square into 2t 4t cube plus 3t into 2t 6t 3t into 2t 6t square into t power 5 6t power 5 plus 1 into 3t square minus 4 into 3 12 t into t square t cube into 6 t power 6, so t power 9 t power 11 whole into dt. So, we need to integrate this f bar or dr bar. Now, we need to find the limits. What is given? The points 0, 0, 0 to 1, 1, 1. That implies x equal to 0, y equal to 0, z equal to 0 to x equal to 1, y equal to 1 and z equal to 1. And here we have x is t. So, if x is 0, t is 0. Similarly, if x is 1, t is 1. Similarly, if you take the second one, y equal to t square, put t equal to 0, put y equal to 0, then t equal to 0. Put y equal to 1, t equal to plus or minus 1. T square is 1, so t is plus or minus 1. But the common value which satisfies all the three conditions is t equal to 1 only. Hence, t varies from 0 to 1. Therefore, to to evaluate the work done, we need to find the integral, line integral of this f bar or dr bar from t equal to 0 to t equal to 1. Therefore, the work done W equal to t from 0 to 1 f bar or dr bar, just now we calculated. So, this is f bar or dr bar. We can simplify this also. Minus 65 plus 65 gets cancelled. So, 3t square plus 3t square, 6t square plus 4t cube minus 12t power 11 dt. Let us substitute this. 6t square plus 4t cube, 6t square plus 4t cube minus 12t power 11 dt. So, we need to integrate this function. To integrate this, we use the formula integral x power n dx, which is x power n plus 1 by n plus 1. So, here 6 into t cube by 3 plus 4 into t power 4 by 4 minus 12 into t power 12 by 12 from t equal to 0 to 1. So, here 2 times cancel. So, this is 2 into upper limit t is 1 plus here also 1 minus 1. So, these 2 gets cancelled and hence the work done is given by 2. Similarly, let us solve one more problem. Problem number 2. If f bar is 3xy I bar minus y square j bar, evaluate f bar or dr bar along the curve C y equal to 2x square in the xy plane from 0, 0 to 1, 2. So, given f bar is 3xy I bar minus y square j bar. Now, we need to calculate f bar or dr bar first. So, r bar is, so it is given in xy plane. So, on xy plane, the value of z is 0. Therefore, we consider the position vector r bar as xi bar plus yj bar only. That implies dr bar is dxi bar plus dyj bar. And now, f bar or dr bar, the dot product between these two values, 3xy dx minus y square dy. Now, we need to integrate this, but this is in terms of two variables, x and y. If we have only a single variable, we can evaluate the line integral. So, for that, let us use the given curve. Given C is y equal to 2x square. That means I can transform y into x using this equation. So, this gives the relation between x and y. So, y is 2x square. If I am transforming y to x, I need to transform dy also. So, let us differentiate dy. The derivative of x square is 2x, so 4x dx. So, completely y is transformed to x. And now, I need to find the limits also. So, completely I am writing this in terms of x. Therefore, f bar or dr bar is 3x into y is 2x square dx minus 2x square whole square dy is 4x dx. So, this is 3 into 2 6 x cube minus 2 square is 4, 4 into 4 16 x power 4 x power 5 dx. So, completely it is in terms of x. So, I need the limits of x only to integrate. So, given 0, 0, 0 to 1, 2, that implies x varies from 0 to 1. Hence, integral f bar or dr bar is equal to x from 0 to 1. What is that f bar or dr bar? 6x cube minus 16x power 5. 6x cube minus 16x power 5 dx. So, which is 6 into x power 4 by 4 minus 16 into x power 6 by 6 from 0 to 1. So upper limit is 1. So 6 by 4, which is 3 by 2 minus 8 by 3. So 6 LCM, 9 minus 2 into 8, 16. So which is minus 7 by 6. This is the line integral in the present case. In today's session, I have introduced the vector integration. In vector integration, there are two types of integrals: line, surface and volume. Line integral means the single integration, surface double integral, volume triple integral. And also I have defined some important definitions and introduced line integral and solved two problems on line integral. So in the next session, we will discuss about the surface integral and also we solve some problems on line integral. So this is for today's session. Thank you very much.